All right, there are these hypotheses here, but a lot of them start with a for all, so we can't do anything until we have something in G. We can't use this one yet, so let's go down here. Now, we need to allow the reader to pick something from S, and we could call it little s, but to make a point, I'm going to just choose some other letter. So I just went ahead and randomly chose the letter U. So since the first line of the proof is going to start with the phrase, let U belong to S, I'm just going to write here, U is an S. Then what we want to show to be true would be this text starting after the comma. So that text that's here, though, needs to be rewritten, replacing the S's that appear in the underlined part with U's. So we actually want to show if U has a cat, then U flies kites. And I'm abbreviating this a little bit. Okay, so if you want to prove this implication, if something then something, how would you do that? Pause, write that in yourself. Okay, so I hope what you said is that you would need to assume that U has a cat. So we'll put that up here, new assumption for us, and then somewhere towards the bottom, you wrote U flies kites. I'll write that down here. Now we don't know U flies kites yet, but that's our goal, that's our destination. Okay, having done that, let us take and figure out what we get due to the fact that U belongs to S. So take a look at the list here of the hypotheses and see which things apply. What can we get? Maybe you'd like to write out, based on some of these for-alls, what things you see. So here's some of the things that I see. So together with hypothesis 3, we can combine this with U belongs to S to get, for example, if U flies kites, then U reads for fun. I'll just write that. U kites, U reads. If we look at H5 and combine this with the fact that U belongs to S, so take a look at 1, 2, 3, 4, 5. Now write this statement here, no longer writing the for all. Okay, this is a general statement when it's for all. We want to write something specific about this thing in S that we have called U. So replace all the R's that you see here, replace these R's with U's, and we get this statement, right? We get if U is a magician, then U doesn't like tea. If we look at the sixth hypothesis, combine these two things together, then we get if U doesn't fly kites, then U is a magician. And I guess, let's see, we've used this for all with the S, this one, that one. I wanted to focus on those first just to see that we get these three implications here. And it appears actually at the moment that we can't use any of these implications yet. So to use an implication, we're either talking modus ponens or modus tollens. There's no additional assumptions. To use this first implication, we need to know that U flies kites. We don't know that. We wish that were true down at the bottom, but we don't know it. Or we need that U doesn't read. To use this next implication, we either need U is a magician, or we need the opposite of U doesn't like tea. In other words, we need U likes tea. We don't have that either. This third implication, we either need that U doesn't fly kites, that's the premise, or we need the negation of the conclusion. We need that U is a magician. So we can't do anything with any of these three implications yet. So we'll wait. At some point later, we might use one or more of these implications, but for now, these implications just stand here. We've got to do something else, and it's all built into the second hypothesis. So the second hypothesis, together with this fact over here, this should lead to U belongs to G. Now, what do we get because U belongs to G? Well, let's take a look. There's this for all and this for all. So immediately my brain goes to these, seeing that we can use those. So why don't you write out what you get because you have this thing called U belonging to G. Pause the video, write out what you get. Okay, welcome back. I hope one of the things you got was combining together with hypothesis 1. What you write down of what you get should not have a for all in it anymore. So one thing you get is if U is a magician, then U flies kites. The other thing you get, you should, if you combine this info with H4, then you should write another statement that no longer has a for all in it. You have, if U has a cat, then U likes T. At this point, take a look, just inventory all of the things that we see. Can any of the implications be used? I mean, does modus ponens or modus tollens apply to any of the implications? The one I see is this implication that we just most recently wrote. We can combine with the fact that U has a cat way up there from the beginning, and we get from here that U, by applying modus ponens, we get that U likes T. I'll just write U T for that. And now do we get anything? It appears that we can take this new fact that U likes T and combine it with this implication over here. Applying modus tollens, we get U is not a magician. And now that we know that U is not a magician, let's see. Oh, look, that's the negation of the conclusion of this implication. So modus tollens will apply now. We combine these two things together, and we actually get that U flies kites. That's what we wanted. And actually, along the process, I'd like you to notice that we never used this implication. So we know this is true, but it just wasn't useful for us in the end. We also know this implication over here is true, but we never used it. So you could mention it in your proof, but it will make your proof shorter to not mention it, and it'll probably be less confusing.